Let's just imagine for a second. What if every important object in our world, we're talking everything from a jet engine to a life-saving medical device, had a perfect digital copy, a copy that tracked its entire life story, every little change, every stress test, in a way that you knew could never be faked or erased? What could we build if we had that kind of absolute certainty? Well, check this out, because this isn't science fiction anymore. What you're seeing here is a real jet engine and its digital twin. It's a complete, incredibly detailed virtual model that perfectly mirrors the physical object, right down to the last bolt, in real time. This tech is already changing the game for how we design, test, and maintain some of the most complex machines on the planet.
Okay, so to really get how this all works, we need to take a step back and answer one simple question first. What exactly is a digital twin?
At its heart, it's basically a living, breathing, digital replica of a physical thing. So think of it like this. A surgeon could practice a really complex operation on a virtual organ that is an exact match for their patients. Or, engineers could test how a wind turbine holds up in a digital hurricane before a single piece of steel is ever put in the ground. It's the ultimate bridge between the physical world and the digital one.
But for all of its incredible power, there's a fundamental problem here, a crack in the foundation that's seriously limiting what this technology can truly do. And that problem, it all comes down to one word: centralization. It's the way a huge chunk of our digital world is built. And in this case, it's a major weakness.
You see, in almost every case today, a single company or a single server is in complete control of the digital twin. They own the data, they manage the history, they have the final say on everything.
And this creates some huge challenges. I mean, think about it. If you have a bunch of different companies, the manufacturer, the parts supplier, the airline operator, all needing to trust the data from that same digital twin, how do you do that? How do you prove where the data really came from, who changed what and when? Trying to audit that history is a total nightmare, and trying to securely sell or transfer ownership of that twin is full of risks. You've got one single point of failure and one single point of control.
So how do you solve a problem that's all about centralized trust? Well, what if you could just remove the need for a central authority altogether? And that is exactly where blockchain comes into the picture.
This chart really lays out the night and day difference. On one side, you have that single point of control we just talked about. But with blockchain, you get a decentralized network where everybody involved has a copy of the records. Data isn't just stored, it's cryptographically sealed into blocks, which makes it immutable, meaning it can't be changed. It's tamper-proof. The whole history becomes transparent and easy to audit for everyone. So here's the key. Trust is no longer something you have to place in one single company. It's literally built into the system itself with math.
And this is why the source material for this explainer calls blockchain a unity layer. It's like the perfect, impartial bookkeeper that brings everyone together onto the exact same page, creating a single, shared source of truth that everybody can rely on.
Okay, so that's the why, but how do we actually use this to build a twin we can trust? Let's take a look under the hood at the blueprint. Now, this diagram might look a bit complex, but the idea behind it is really brilliant, and it boils down to two core components. Right in the middle, you have the Ethereum smart contract. Think of this as the digital rulebook, or a digital notary. It's code that automatically enforces the rules and logs every single transaction so it can't be changed. No one person can just decide to alter the rules. Then, for the actual data, the massive 3D model files, the system uses IPFS. Instead of one server, IPFS is a distributed file system, which means the data is chopped up and stored across many different computers. This makes it super resilient and almost impossible to tamper with. Put them together, and you have a system with no single point of failure or control.
And the creation process itself is secured and recorded on the blockchain every step of the way. It all follows 4 clear phases. First, there's the design. Then, it's built into a true replica using data from the real world. After that, it's rigorously tested and validated. And finally, once everything checks out, it's delivered, and its ownership is officially registered on the ledger. Every single one of those steps is a permanent, verifiable transaction.
So when you start to put all of this together, you realize we're talking about something way bigger than just improving one piece of technology. This is really about building a completely new foundation for how we interact with physical things in our digital world.
So let's just quickly recap what this new model really gives us. Number 1, secure and trusted traceability, from the moment an object is created to the day it's retired. Number 2, an unchangeable permanent history of every single interaction. 3, decentralized governance, so no single company is the boss. And finally, number 4, a truly secure and verifiable way to transfer ownership.
And this, right here, is the biggest takeaway. We're not just talking about a better way to manage parts for a jet engine. This is a blueprint for creating a tamper-proof history for any physical object. A rare piece of art, a luxury watch, a critical shipment of medicine, anything where authenticity and a verifiable history really, really matter.
And that leaves us with one last big question. If any object in the world can have its own perfect, unchangeable, and completely trustworthy story, what new economies, what new industries, what incredible possibilities are we going to build on that absolute foundation of trust next?